Welcome to Metaverse Entangled.
So, hello, Didi. Welcome to the podcast. It is my pleasure to have you here, and a very happy belated Women's Day.
Uh, Thank you. Thank you so much. It's my pleasure to be here as well.
So, without wasting time, let's start getting into the questions. So, first, Didi, tell us about yourself, and also tell us something unique that would be an exclusive Metaverse Entangled fact.
Hello everybody. Like my name is Niharika Verma, and I'm currently in my final semester of masters at IIT Patna. Here I am. Basically, my project is on the quantum error correction, that is quantum computing, and I have strong interest. The unique and exclusive sort of metaverse entangled fact is that I never planned to study or to get into quantum computing initially. I always wanted to study high energy physics, but somehow I landed up here, and I'm currently loving this. Like, if I would have studied high energy, I would have loved that as well. But this is where my true adrenaline rush lies, I guess. And apart
Amazing,
from
Didi.
the studies and stuff, um, I love photography. Quantum computing is all about uncertainties, Heisenberg principles, and come to think of it, photography is something that you can capture the moment, certainty, the position certainty of moment.
Wow.
I know it is very bad analogy, but yeah, it came to my mind. So
No, like I'm very happy that Metaverse Entangled is acting as a platform here to, give the audience this exclusive fact. This will come in somewhere, a correlation. So moving on, Didi, like can you take a few minutes to explain our audience what quantum computing actually is? What is it all about?
see, in classical computers we have bits 0 and 1, and in quantum computers we have qubits. That is like between the 0 state and 1 state there is a superposition as well. So due to the superposition, the qubits can exist in multiple states simultaneously. And there are three things, basic things, which makes up a quantum system: superposition, entanglement, and quantum interference. Like, entanglements help the qubits to stay connected, and the informations are uh, from one qubit. Say, we generally call them Alice and Bob. So if they're far apart, so information can be instantly transferred without the in no matter what the distance is. In And the third part is the interference. So quantum interference basically helps to like manipulate states and like drive the computations towards the correct goal, correct answer part. So yeah, this is, and quantum computers can help us to solve many problems which are not yet which are too difficult to be solved by a normal computer. So that's why we use quantum computers.
So we'll get a bit more elaborate on this. So what successes has quantum computing made so far, and what do you think the potential successes are in the next 10 years maybe?
um, you guys must have heard in the news about Willow and all the big shot companies uh, announcing their mm, quantum
Personally,
computing
I
chips.
see a lot of development in the hardware aspect. When somebody releases
Yeah,
like Majorana example.
yeah, Marana and Willow and every quantum D-rings have D-waves have sorry, D-waves have I had heard it some like a week before they have achieved quantum advantage, which is a huge thing, like really huge. So currently, every like most of the companies are working towards the advanced hardware part, and then the like basically if we it is not just about the hardware. Like, if we increase the number of qubits, the what kind of operations that we are going to perform on them, that would also be substantially increase. So current successes are there in quantum cryptography as well. You must have heard about quantum key distribution and stuff, and drug discovery, quantum simulations, error energy eigenvalue solvers, all of it. They have like they hugely depend on. They would be they are like they would be benefited don't want to say most, but yeah, they would be significantly. And then quantum machine learning is also an emerging field, like optimizations as well, optimization in logistics and supply chain, every domain, quantum finance, many domains as such.
In the
But
future,
yeah.
in the future, something this can be like groundbreaking. This can do this. You're very sure short of something like that.
See, now we are in NISQ era. The systems have noise. So in future, if we are able to taper those noise and reduce those noise further, so means the coherence time of the system would increase. And
Right.
if that increase, the computational part would also be increased, and it would be a big milestone. And we are not away from that. We can achieve that in maybe 5 years or even less than that. So
Right.
for me, that is a huge milestone. Like, also, if that happens, commercially viable quantum computers would also be emerging. Earlier we used to have CPUs, now CPU plus GPU. So you never know, there would be coming a time when there would be CPU plus GPU plus quantum processing unit as well. So that is a huge thing.
It's really, really good to know. Really good to hear. And as you said, you work on quantum error correction. Can you please tell
Yeah.
us about it, Didi? Like, what do you do exactly?
Quantum systems are very fragile. Like, any disturbance in the environment can decohere the system entirely, our quantum system. So, by error correction, there are various codes. Like, by error correction methodology, we try to reduce the error, or like move towards more fault tolerant computer systems. Like I said, this is we are currently in the NISQ era. So our main focus is to get into like more fault tolerant computer systems with higher uh, time and all. And secondly, I can phase estimation, quantum phase estimation area as well. So that is an important part of quantum chemistry, or you say quantum cryptography as well. So this sums up my basic work that I do.
Right, Didi.
In No, like, I basically work in neutral atom quantum computers. They can be four types of bosonic, like the photon-based quantum computers, trapped ion quantum computers, superconducting, and neutral atom. So I basically work in the neutral atom domain. Yeah, that's it.
So, yeah, nice. So, moving on, if one wants to take a career in quantum computing, what are all the entry points he has, both theoretical and experimental? And what are some immediate sought after places or roles that one can preferably look into if he wants to get a good job security in this?
Job security wise, I would say IBM Quantum. There are various startups in India as well. Like, one is QPI. QPI is it's ISA Bangalore. It's in Bangalore, and there are many startups. And how to get into like quantum computing, for the theoretical aspect, you should be knowing quantum physics and linear algebra. Okay. Along with that, if you have a good knowledge of Python, and you can start learning about Qiskit or Kirk or like Penny Lane, any kind of quantum computing libraries. And if you want to go into the experimental part, I would say you can begin with quantum optics part and EIT part. Means that atom sorting part, atom loading parts, qubits loading part, all of those areas. Experimental and like career wise, both of them are like, experimental is also needed, theoretical part is also needed.
Do you personally
So
think that if I, more than the computation and what to say, like theoretical aspects, experimentalists are much more needed in quantum computing right now because we need more developed, advanced, capable hardwares. Do you think that?
both of them are needed. See, they are the two sides of the same coin. You cannot have an experimentalist without a
Do you think that
theoretical.
just we are a bit theoretically too advanced now? We just need to focus more on experiments. Theoretically, we have reached a very big level.
I guess that's not the case,
Right.
because see, whatever the theoreticians like propose, the experimentalists try to model them.
Mm-hmm.
And suppose I say we are working for 400 qubits. So 400 qubits is a huge amount of physical qubits.
Right.
So for an experimentalist, doing such kind of work would be a very tedious task. And for that large number of qubits, you would be the system would be having some errors, loads of errors as well, due to the environmental factors. So a theoretician's work would be to model those errors, like how to make the system more capable, fault tolerant part, and both are necessary. I
Okay.
cannot say that an experimentalist is
You
more
okay? Then
important.
fine. That is a bit hard consoling, personally.
See, I work in the theory part as well, so I won't say that in theory part, the theoreticians are. It is not the case. Like every day, new papers are coming. Most of the work is theoretical as of now.
And what computation skills do you think one must start developing in order to learn quantum computing? Are there any prerequisites?
You should like have a basic idea about Python, I guess, and you like basic programming part. But apart from that, I don't think that much more is required. Uh,
Next, moving on, it's a kind
You
of a
should
fun
have the
question.
zeal, sorry, like you
Yeah.
should have the zeal to study quantum computing, or like you should be enthusiastic about it. Yeah, I want to study quantum computing. It's the zeal that
Right,
matters the
Didi.
most in the
Right,
end.
right. Moving on, Didi, it's kind of a fun, hypothetical, maybe futuristic question. Do you think a quantum GPT is possible? What are your expectations for that, Didi? And if I plan to, uh, would develop something like that, what would be your advice to me? Like, if I want to develop this and launch this, what would your advice be? Like, how should I get started?
See, the quantum computing is still in its early stages. Okay. So, like, but the researchers are focusing on various quantum variants of transformers and quantum self attention mechanisms. There are works going on in this area as well, like CUDA and GQE. GQ is generative quantum eigensolver. It allows GPT model to create quantum circuits. So work is going on in this area, but to make a full-fledged GPT model, we would be requiring a full-fledged quantum computer firstly.
Right.
So that itself is a task.
Mhm.
If we are able to make such computers, definitely we would be having GPT, and it has various benefits, like the training times for AI would be sufficiently very much reduced. And as you said, how to get started, I'd say it again: Python, Qiskit, the basic part, and then you can go to machine learning, AI/ML, deep learning, machine learning part,
That all,
and
like,
then
we have to get into the classical deep learning frameworks, right? Because I don't think
yeah,
it can.
firstly
We'll have a classical quantum hybrid model.
yeah, like first you can get into the classical part, and then you can get into the QML part. Use PennyLane, TensorFlow Quantum, sorry, not TensorFlow, TensorFlow is for classical. There are Qiskit machine learning modules as well, so you can use that. It would be fun.
So yeah, we'll make a note of it. And moving on, we also know that you took part in the MIT Quantum Hackathon, and you even secured a place there. So congratulations from Metaverse Entangled first. And can you just share how the experience was and how a quantum hackathon is different from a regular hackathon?
See, in the problems here were more of the physical aspects, like our problem was related to variational quantum phase estimation. Okay, so in classical, first of all, it was really what to say. I'm out of words for it, but it was a great experience. Great, really, really great experience, and we were for the I chose the problem for quantum rings part. So the question was related to the optimization of variational phase estimation. It is like it was more related to the physical aspects of the quantum chemistry or the unsolved problems that we, a set of unsolved problems that we have. So yeah, in classical, like in normal hackathon, I haven't participated much in like normal hackathon, so I don't have much idea about it. But they give you a question, and then you have to use the basically your software skills are tested there, like software and critical reasoning, thinking. Same thing, yeah, but more of like application of uh, physics or chemistry or something related to that here.
Mhm. So yeah, that is really good to know. And what problems do you think quantum computers are facing currently, and how do you think we can fix them?
One of the problems which I said is like if we are increasing see the quantum computers
Noise.
now, are- they are like the stable ones are in the number of physical qubits are less. So if we
Could you
are
just tell us
scaling up,
about did they like what do you mean by noise exactly?
noise is any disturbance to the system. Suppose if I'm tapping, it is a very layman example, but if I'm tapping my table here, it would create some noise. I'm
Right,
not able to perceive that noise, but my
right.
system is so fragile that it would be perceiving that noise and the entire state would get destroyed. So my quantum information would also get destroyed. So right now, the if quantum advantage is to be achieved, we need to focus towards the uh, fault tolerant part. We need to make our systems more fault tolerant. They can be like IBM has approximately IBM had there was this announcement of IBM. I don't remember it exactly, but it was for about 100 qubits. 100 qubits is a huge amount of qubits. So
Okay.
if we can scale up to that and that remains stable, we would be getting a new quantum computer really soon. Basically QPU chip as well. So like
Easily. We can
quantum,
just we'll hope.
yeah, hope so. There are various other problems as well, like
Hmm.
um, some systems are to be kept in a cryogenic condition. And suppose if they are to be commercialized, cryogenic conditions are not that easy to
Right.
be built in day-to-day life.
Hmm.
Like superconducting qubits and basically all of the quantum computers, if they are kept in cryogenic condition, they perform really well. So that is also a hurdle here. We cannot have cryogenic conditions in our room. Um,
And we started off with a Women's Day wish. So next we have some questions related to women in science, and these questions are from our audience. So the first question would be like, what are your comments, and why do you think there is a very unfair gender ratio in research areas?
um, like, see, I would not say there is a unfair gender ratio in women in these areas, but
Hmm.
basically this is due to lack of support, I guess, that we get from our family or our peers. Like if we don't have, suppose you are an experiment. I'm just giving an example. If you're an experimentalist, if your experiment is uh, going on along for a day or two,
Yeah, right.
people make an
I
assumption
understand.
that you are a girl and you won't be able to, but that is not the case. It is just there in their heads that, oh, she's a girl, she cannot, but that is not the, this is the main thing that demotivates women to get into these areas, I guess. And patriarchy. So like if Also role models as well. Out of many physicists that we know, only Marie Curie is the one female physicist that we are like that that is this famous.
So
So
do you think
role,
it has kind of become a stereotype that it is men who do science? And but
it is
when we
not.
say that, it sounds like very it it does not when we say that statement, it does not very makes a lot of sense, and we don't like it even when we say it. We just want to change it, but we don't see any noticeable change happening, even though there is a change happening drastically, but it is still people are stuck on the stereotypes.
Yeah, people are stuck on these stereotypes, and even like if we have a strong support group here, so strong support group, strong role models, so more girls would be coming out to pursue science. And if you take the case of India, in India, majority of the people, like after bachelor's, I don't want to say.
It's easy. Yeah, I'm getting it. And in what
It
ways
would
do
be
you
going
think we can find easy? In what ways do you think we can break all these stereotypes and increase the graph drastically?
female role models. Like, see, Sunita Williams is so famous. She is an astronaut. So many girls, like when I was a child, I wanted to become an astronaut. Sunita Williams was my role model. So like that, if we have something, a few years back when first image of black hole was released, there was this woman behind those works. I don't remember her name. So she kind of inspired many other women to pursue this field. So
Right.
like that, like if we have many female role models, or if we have a significant number of female role models, and basically it is a willpower. If we want to do it, we have to do it. It is like that.
So
And
that depends on that.
government part is concerned, so if they female incent I if I say incentives, it would be biased. It would be like feminist sort of thing. So I want uh, role model part would be like
I get it. And
we don't sorry like it
uh,
came to my mind, sometimes we don't feel inclusive as well.
sorry.
Inclusive, like
Okay. Huh.
if in a lab there are five men and you are a single girl, you will
Hmm.
be left out for most of the time. So that is also a case.
So that only it has to be the individual's role in changing that. Like we can't be a.
It has to
It,
be a combined effort from both the ends, not just the women, from
Mhm.
both the ends.
I believe.
See.
So, and I asked this question to all my guests. That is, if you could go back and fix one thing from your past, what would it be and why?
None.
So you're extremely happy with where you are and what you're doing today.
It is not about being happy. Like I am who I am today is who I am today because of my past mistakes. Had I not done those mistakes, I would not have landed up here.
It's a very good response. Yeah.
So I regret nothing. Nobody should regret anything. We are physicists. If we change the past, the timelines would be disturbed.
This technicality could have been avoided in this
What?
philosophical question. Maybe this technicality could have been avoided in this philosophical question. We are physicists, but still, anyways, it makes a very good amount of sense. And
So,
like no, I completely appreciate it, Didi. And we are nearing the end of the podcast. And what would be your final advice to all the junior students?
see, research is sometimes you are very happy, you are elated by your results, but sometimes it can be quite gloomy too. But you should never give up.
Right, Didi.
Like the graph is sinusoidal. This
Right,
is
Didi.
what keeps me going. Like one and yeah, like all the best. Keep
Right.
doing the research. We need more physicists, more researchers in India.
Right, Didi. Thank you. And I think we are done, Didi. Thank you so much for sparing your time. I had a very great time with you. And I hope you also had a very great time, and I hope you liked the questions. Thank you so much, Didi.
Same. Thank you.
Thank you, Didi. Have a good day.